Yes.
Maha, Aisha.
Yes, sir.
All right. Okay, class. So we started with this question, and I think you haven't written anything. We have to discuss the solution of this. So I told you the best method to calculate such questions is these are two possible methods which I have written on the screen. You can use this. Your answer will be done. See, right now we are doing this question for a disk. Like if there's a disk and there has been a portion that has been cut from it like this. So this crescent part that is available and we are calculating at center of mass. Now class, the possibility is that you can, the possibility is that you can have a sphere also from which a smaller sphere of r by 2 has been cut. So similar questions are there, method remains the same. What we'll do here is, see, for the center of mass, we are going to calculate the mass of the leftover portion. Okay, and then we are going to put it in the formula. See how. Let's say this is our axis as I discussed till yesterday. Now let's just write down what are the values. First, I need to get the mass of this part. So look, when the disk was complete, so mass of disk having area pi r square. When the pi r square means that complete big disk before getting it cut. This radius was r, so pi r square would have a mass m. So mass per unit area, mass per unit area will be, what will it be? Mass per unit area?
M by L.
M by pi r square. A is pi r square, okay? So m by pi r square. Now for unit, you know, unit means in 1 meter square, what is the mass that you know? So in 2 meter square, it will be double. 3 meter square, triple. Now when you know for 1 unit, you can calculate it for anything. So mass of the disk having area. Now what area? The smaller one which has been taken out, whose radius is just r by 2. So its area will be pi r square by 4, right? Mass of disk having area pi r square by 4 will be m by pi r square into pi r square by 4. So pi r square gets cancelled and the mass is m by 4. Now you have the mass. Now let's write the coordinates of each and everything. Let's say this is the origin. Always have a reference axis in rotation, be it any topic, any of your topic, have the reference. Yeah.
Why are we taking pi r square by 4?
Radius of the smaller one is r by 2. R by 2 has been cut. Area of this will be pi r square. Now see, if we write the coordinates of the bigger one, okay, let's write. The mass here, see, here the mass is m of the bigger one. When we are writing m1 is m, while x1, that will be 0 because for this mass it is exactly at the origin. But for this mass, here the mass is m by 4 as we have calculated. Second mass is m by 4, while the separation is r by 2 from the origin. Now nothing, you just have to calculate the position of the center of mass using m1 x1 plus m2 x2 divided by m1 plus m2. That will give us m into 0 plus m by 4 into r by 2 divided by m plus m by 4. This will make it m r by 8, or I'll write it like this. R by 10 will come, no? This will be m r by 8 into 4 by 5m. Will be cancelled. This is 4, this is 2, r by 10. So r by 10 is position of the center of mass. Now, if you have a sphere, for example, what you can do, volume of the sphere, you means you have to mass of the sphere having volume 4 by 3 pi r cube is m. Mass per unit volume, that you'll do, because see, for sphere you will not calculate the area. The center of mass will be inside the figure because it's a solid figure, or a cylinder like this. So shapes can be different, method will be the same. If it's sphere is a common, another common one, most common is the disk one. That's why I've discussed the disk one. What you do, mass of sphere having volume 4 by 3 pi r cube is m. Mass per unit volume will be m by 4 by 3 pi r cube. So mass of sphere having radius r by 3, r by 2, whatever is it, 4 by 3 pi r cube, you put the value of r, will be you multiply. Same method. So for by this method, you will be able to calculate everything. Am I clear?
Yes,
Okay, all right. Now we'll come to the motion of the center of mass. You haven't written anything, no? Till
we
here,
have.
you have written till where?
We wrote the question on the like the two ways.
These two steps you have written, all of
Yes.
you?
Yes, ma'am.
Okay, great. Then come here, please just copy. And please copy and text me done in the chat box. I'll have to offer a prayer right now. I'll just come, but just text me in the chat column. Meanwhile, just copy. Okay, don't unmute. Okay, I think by now all of you must have written. Okay. Now see, motion of center of mass means till now we were just calculating the position of center of mass. Position of center of mass means you are calculating where is the center of mass located, correct? Now see, once you know where is the center of mass located, if the body is moving, so that center of mass, wherever it is located, will have its respective velocity also. The whole body is moving, and we talked that all these different particles are present which are representing the individual velocity. If all these particles are present with their individual velocities, the center of mass, which is the prototype of all of this, will also have a particular velocity. So center of mass will be, position is this. Whenever we have to calculate the velocity from position, we differentiate it. Same thing we are going to do over here also. See, from here, okay, I'll continue from here only. What we can do for the velocity of the center of mass, masses are constant. It's not that masses are getting changed with respect to position or the speed. So what you do, mass will come out dr1 over dt plus m2 dr2 over dt. Like this will be carried forward till mnth drnth over dt. This whole thing divided by the mass, total mass. Now look, from here, tell me, what is this? dr over dt.
Velocity.
Very good, Maha. Velocity. The masses are present with their separations. Let's say this is the origin. This will have its velocity v1, this will have velocity v2, v3 up to vnth. So all these are individual velocities only. This is v1, this is v2, and all of it, this will be vnth. So what do you do here? For the velocity of the center of mass, m1 v1 plus m2 v2 plus m3 v3. Like this will go on till mnth vnth. Divided by the total mass, that is m. This is the velocity of the center of mass. Now, from the velocity, if I need to calculate acceleration, that is also not difficult. You know, acceleration, you differentiate this. Look, this is the velocity of the center of mass. If I differentiate this for acceleration of the center of mass, basically, you differentiate the velocity of center of mass. So what will I get? d over dt of this whole term, m1 v1 plus m2 v2 up till mnth vnth divided by the total mass. So similarly here also for acceleration of the center of mass, m1 out d v1 over dt plus m2 d v2 over dt, m3 dv3 over dt. Like this will go on till nth. Nth means any number. Where you put the number that is given, number of particles. That's why n we write. d vnth over dt divided by the total mass. Total. Okay. So from here we can say this is
Acceleration.
acceleration. Correct. This is a1. This will be a2. Like this will go on further. So acceleration of the center of mass will be m1 a1 plus m2 a2 plus m3 a3 till mnth anth divided by m. Like this. This is how you can calculate. Few more things we'll see from here only, but later on. So this is very easy to calculate. See, position, same similar formula like your position. Position was m1 r1 plus m2 r2 like this. This is m1 v1 plus m2 v2. For acceleration, m1 a1 like this, divided by the total mass in every case. There is one very good question in your NCRT or NCRT example based on a pulley that we'll discuss right now. That will give you a good practice of accelerations. So, okay, we'll discuss this question later. We first write down this question. From your motion of center of mass, this is the heading here. All right. So see in this, I'll just this part. See, the acceleration is directed upwards, and here the acceleration is directed downwards. So what we do, we have to calculate the acceleration of the center of mass. So for that, you need the individual accelerations first. So what we are going to do, we are going to calculate the acceleration first using the concept of the laws of motion that we have already studied under the pulley problems, pulley mass systems. So here we have the tension force upwards. Here also tension force acts upwards. And downwards here, 50 will act, 5 into G, that is 50 Newton. And here 100 Newton will act. When you make up the equation here, you are going to follow the net force is equal to mass of the body into acceleration. This is what we are going to write. Now, net force has to be tension minus 50 or 50 minus tension. And how do we decide that? We decide it by seeing whichever will have the direction of acceleration. Here, acceleration is directed upwards, so tension will be positive. So, first equation will be T minus 50 is equal to 5A. That's the first equation. Here also it could either be T minus 100 or 100 minus T, but direction of acceleration is taken positive. So 100 minus T. 100 minus T is equal to 10A. That's the second equation. Let's add that. If we add them, 100 minus T is equal to 10A and minus 50 plus T is equal to 5A. If we add it, tension will be vanished. From here, 50 will be left and this will be 15A. So acceleration will be 50 by 15. 10 by 3, that is 3.33 meter per second, 3.33 bar meter per second square, or even you can write this as G by 3. 10 by 3, so G by 3. Now look for acceleration. Now that part has just given us the magnitude of acceleration. This is from the laws of motion part. Now let's come to the rotational part. The rotational part in the sense is center of mass part. See, acceleration is actually a vector quantity. So individually, if I see the acceleration for both the masses, look, when I talk about the masses, M1 will be 5 kg. It will have an acceleration. Similarly, M2 will be 10 kg. It will have its own acceleration. Now, acceleration in both the strings is same. Both the accelerations are same. That's why we have taken it as A. And tension is also the same. That's why we have taken it as T. So one thing is clear. This will also be G by 3. This will also be G by 3. G by 3, you can take the 3.33, 10 by 3, anything. Now, one acceleration is directed upwards, second acceleration is directed downwards. So you, according to your sign convention, take upwards positive, downwards negative, or anything. Like if I say, not right, sorry, up. If I say up is, let's say, positive and down is, let's say, negative. Positive, which one is up? First one, M1. So this will be positive and this will be negative. Like this. So now you can put in what have we studied for the acceleration center of mass. M1 A1 plus M2 A2 by M1 plus M2. M1 is 5 into G by 3. This will be minus when this will be multiplied. So 10 into G by 3 divided by 5 plus 10. That will be equal to, this is 5G by 3 minus 10G by 3. That is minus 5G by 3. From here, denominator is the same 3. 5G minus 10G is minus 5. So minus 5G by 3 is there. From here, the denominator. And this will be 15. So that is equal to G by 9. Minus G by 9 is the acceleration center of mass. Got it?
Yes. Why did you take like the actual value instead of taking, why did you take like G by 3?
No, no, you can take anything. Actually, this once it came in the neat paper or something, so there the options were written in terms of G by 3. You take it, that's what I was saying. You take it as 3.3. That is correct. In your papers, you should write 3.3. Here, actually, when you write, no, you write this as 10 by 3. This one. So that 10 is written as G by 3, and it was once in the option. So that's why in manner of just completing habitually I've written it, and your answer will be right here. Just substitute the value of G as 10. So whatever is the value, same thing you can do. Okay, you can put 3.3, 10 by 3. It's better if you put those values in fact, because G doesn't have the value as 10. In that question, it was mentioned to take G as 10. But just for ease, just for the class calculations ease I have taken. But yes, class, take 3.33 when the values are given. One more question we'll see. Another easy question before we move. Please copy it from here. See, here in this question, it says calculate the velocity of the center of mass. So sign convention is up to you. That won't be mentioned in the question. Any sign convention you can take. So two bodies are. This is like a collision. Question, similar question we have already studied in collision. So here, see, M1 is 2 kg, while M2 is 5 kg. Now their individual velocities V1, V2, these are left. So you pick up any sign convention. Let's say right is positive, left is negative, any sign convention. Right is this will be positive, this will be negative. So this will be 5 meter per second and this will be minus 2 meter per second. So velocity of the center of mass will be m1 v1 plus m2 v2 divided by m1 plus m2. 2 into 5 minus 5 into 2 by 5 plus 2. Straight away, 0 is. But you can get a non-zero value also. Okay, very small, easy question, formula based. Please write it quickly. Now, a few more things I'll discuss with you. And there is one very important question from NCRT that we have to discuss. Okay, I think all of you have written others also. Done? Okay. See, now coming to the force on the center of mass. So as we've already discussed, the forces are of internal and external types. So here, how will we have the internal or external forces? See, when we talk about whenever you have any system, let's say this is some system is present, and we know what is the system, the part that is under our observation. Let's say its center of mass is something. So when we talk about the center of mass, if any force is applied on the center of mass, if any force is applied, this force is termed as the internal force. In this case, this will be the internal force on your center of mass, because your center of mass is a part of your system. So internal forces are part of our system. That's why we have these forces as the internal forces. And if there is any external force that comes onto the center of mass, these are termed as the external forces. Okay, so internal forces will never change the center of mass because they are a part of your system. But external forces can shift the center of mass. Here this whole problem of system and surrounding is the same as we have discussed earlier. System plus surrounding
So
is
external force acts on the whole system.
act outside the system. Yes, the external force will act outside the system. So this is what I was telling you. The internal forces, they are a part of the system of particles, but they cannot affect the center of mass. While the external forces, they have a system of particles. They act on the system of particles, but they can affect the center of mass. External force will be zero in most of the cases, so conservation will occur. That I'll tell later. See, I discussed this formula of acceleration with all of you. Means instead of m1 plus m2, I have written the total mass as m, but that was the same thing. So if I want acceleration of the center of mass, I can write this as m1 a1 plus m2 a2 plus mn anth divided by the total mass m. If I shift this m over here, MACOM is equal to M1 A1 plus M2 A2 plus M3 A3, M4 A4, M5 A5 and all till MNth ANth. Can anyone tell me what is this?
Force.
Very good, ma. This is the force. This will be the force on the center of mass, force of the center of mass. And this is equal to individual forces. See, M1 A1 is the force on first particle, plus F2, plus F3, plus F4 till Fnth. This is not M1 F1. Okay. Now, this is a very, very, very important question. Very important question. Yeah, you can just mark a star or an important sign or an asterisk in this question when we discuss. It's a question from your NCRT itself, though. And this is a question, but the topic is the conservation of center of mass. So instead of, there is nothing to teach you in conservation of center of mass. Conservation of center of mass means net external force is not acting, center of mass is conserved. Now, just understanding it like this is difficult. So through this question only, I'll tell you that concept. Okay. But first, write down these things before this. From here. Done. All completed.
Yes.
See, let's practice this question. See, this basically says what? Understand it through the figure. That's why I have the figure already drawn. It means a man of mass small m stands on a wooden plank, a log of wood, whose mass is capital M. Small m, mass of the man, this wooden plank's mass will be capital M. So the person is standing. It's like the plank is floating on the river, and there is the edge, and the man is standing on the edge of the plank, and with the help of it, he will be crossing the river. So it says that the question says a man of mass M stands with a wooden plank of mass M floating on a river near its bank. The man starts walking on the plank towards the left. It means now he has to move towards the bank, towards the edge of the sea river. So what will happen? He'll obviously walk on the wooden plank so as to get towards the side. So when he walks, imagine you are walking on a wooden log. What will happen? Is it rigid? Is it connected to the river? Is it fixed on the ground the way you walk on stairs? That's not there. Even have you all done boating? I think most of you must have. There, when you
No, no.
land on the boat, hmm?
I just said yeah.
Okay, all right. So when you actually jump on the boat, what happens? You don't feel a firm, stable surface. Definitely, boat hazards.
The boat will move a little.
Exactly. The boat will move because what happens is the conservation of center of mass. Center of mass has to be conserved. So when the person will walk on the plank, imagine yourself, you're walking on a wooden plank is there, and that's connected towards the edge, and you're walking on this wooden part. So what will happen? As you will be moving forward, it will be pushing backward itself. So what happens? This kind of situation. I don't focus on L and all that I'll explain. You just see this small story thing. So when he comes in the middle part, the plank is already drifted by L by 2 back. There's the story, what the question says. It says how much distance the plank has moved. Means what? From the periphery, from this bank, how much distance has the plank moved backward? Remember one thing. If external force is not acting, your center of mass will remain conserved. There won't be any effect on the center of mass. Okay, center of mass will be conserved. Reason is that, see, the net external force is zero, so that becomes your isolated system. We will see the conservation of momentum as well. So conservation of center of mass means whatever was the center of mass in the first part, even after moving, the center of mass will be the same, because there is no external force. External force only changes the center of mass. See, what's your system? This man and this plank is the system. The man who is walking on this plank is the system. Anything else that is acting will be considered external, and anything within here. Like, see, there will be a gravitational force over here, and we also. Here, a normal reaction will also be there. So these are all internal forces. They will not affect the center of mass. Okay. Now what we have to do? We will calculate the center of mass in both the cases. Let's calculate away the center of masses in both the cases. And according to conservation of center of mass, it will be the same. We'll go bit by bit. Let's see the first part. First part, when he is at the periphery. One, let's say this man. His mass is given as small m. X1 will be, tell me, this is your origin.
0.
Where is the man standing?
L by 2.
Where is the man standing from the origin? This is like your. Yes, Neha?
X plus half.
Man is here. Let's look at the first case. Man is here. Origin means that river bank that we, anyways, you can take origin from your end, by the way. But see, you have to see how did I decide my origin. One thing before we move on to this discussion is that we have to see from the bank how much the plank has drifted. So that's obviously I have to take that as the origin so I can get that length. Otherwise, I've told you, you just have one axis. Anyways, this is our main reference axis, that is x equal to 0. Where is the man standing from the river, from the bank? L. This is your origin, no? Class x equal to 0, this part. So he is standing at a distance of L. Clear?
Okay.
All right. Now let's talk about this
I
plank.
thought you took the middle part as the origin.
Origin. No, no, that is not the. That is the center of mass. Remember, we discussed a question where rod was there of length L. So center of mass lied exactly in the middle part. So here also, there the center of mass will be lying. Means if I calculate M2, this will be capital M. And what's the location of the center of mass for the plank? I cannot take the entire plank. We are not dealing with the whole body. I'll just take its center of mass. So this is located at a distance of L by 2.
L by 2.
Yes. Now here, if we apply the center of masses formula, means if I calculate, let's say this is x. Okay, x is there. So yes, someone try this. Nabila, can you tell me? See, everything is written already here.
M1 X1 by
M1, x1, yes. Put the values.
M plus ML plus
M into L plus
M into L by 2
capital M into L by 2, right? Divided by
M plus capital M.
yes, small m plus capital M, correct. This is one part. ml plus ml by 2. We'll solve that later. This is one part. Now see, now when the plank has shifted, now we have to see few things. What are the changes over here? So first object was the man. Hai na? So M1 here in the second case will be small m. Now tell me the position of the man now. From the origin.
X.
L by 2.
L by 2. From the origin. See, let us assume something. Let us say that the person this has drifted by x. The plank has drifted by some distance x. The man who was at a distance of L earlier now has moved forward. So definitely this part is L by 2. But this part, because we will see the man is there from the origin, that is x. He is at the periphery of the plank now because the plank has shifted backwards. So this from here to here the separation is x. X is actually not something that we have assumed. So this will be x. Second mass will be mass of the plank. Now tell me this class. Where can you see its center of mass from the origin?
X plus L by 2.
X plus L by 2. Okay. Here this the center of this plank has shifted to L by 2. Already it has shifted by x distance. So total will be x plus L by 2. So this will be x plus L by 2. Yes, somebody else. Maha, can you try the center of mass?
M into X plus capital M into X plus L by 2 by the sum of masses.
Yes, correct. Very good. By the sum of masses m plus small m. Now see, we have the concept of conservation of center of mass. Conservation of
Ma'am,
center of mass. Yeah.
I still don't understand how like x1 is equal to x.
X1. See, from the origin. From the origin, you take the position of the person. Like here, initially there was x was equal to 0. There wasn't any x. So what was the separation? That was L.
L.
Yeah. Now the plank has shifted. Means there is some distance x, and problem is that man has also come forward. Man also came forward, plank also has shifted backwards. If the man was here only and the plank was here, then we could have said something else. It has shifted again by L distance or anything. Man is coming forward, plank is going back. So he is at the periphery. So from this part to this part, what's the length? You will see everything from one origin. Make one axis. Axis part I'll do in rotation part. Here everything is translation. But in the complete chapter, make one origin sort of axis. Like for rotation, we will also make our
Okay,
axis.
so we are only using L for the plank itself, but then other than the
Yes.
plank, we are using some other variable.
The separation we are using some x. This x is not a part of our question. Like my final answer should give the value of x. It is asking how much the plank has moved. So I have assumed, okay, let's say it has moved by some distance x. Okay. Now
Okay.
got it? See, conservation of center of mass, if external is 0, both of the center of masses will be the same. So this is ml plus ml by 2. ml plus ml by 2 divided by m plus n will be equal to this. mx plus mx plus l by 2 divided by m plus m. This bracket denominator will be cancelled. That makes it ml plus ml by 2 is equal to mx plus this. Also we can open up the bracket mx plus ml by 2. Shift everything on the opposite side. ml plus ml by 2.
Won't ml by 2 get cancelled?
Yeah, this will be cancelled. ml by 2 will be cancelled, correct. mx is there, ml will be multiplied, mx, yeah, this will be cancelled. Shouldn't write it. ml is equal to this minus, no, here we already have the values of x, so answer is here. See, let me just take x common directly because I want to get the values of x. So this will be, if I take x common from here, small m plus capital M is equal to ml. So x is equal to ml divided by capital M plus m. This is the value. This much by this much distance it has moved. So m, capital M, small m, and L were given in the question. So now our answer is correct. If I was getting anywhere x, then that would have been incorrect because x is nothing. That I just assume that this much it has moved. Am I clear?
Yeah.
Yes, ma'am.
Everybody? Nabila, you also?
Yes.
Okay, then great. All right. Note it down. Mass done. Okay, see now there is one question based on conservation of momentum of center of mass, that is done. Otherwise, we'll come to the kinematics of rotational motion. So just revise your kinematics of second chapter, motion in a straight line. Similar questions will be there, everything. It's just that we'll see the rotational analogs. So that we'll complete it in the next week only. Okay, now you can leave. All right, thank you so much then. Okay then.
Thank you.